Okay, hi guys. So I've been using the ESP32S3 modules, XIAO modules from Seed Studio, like this one here. And you might notice that these things have pads here for another connector, but just the modules by themselves don't have the little connector there. So there is also a Seed Studio XIAO Sense module that actually does have a little socket there, and comes with an extra little board, and it has a little camera attached. And if you look at the website, they sell it. It says, okay, it's got AI detection, microphone, and so on. But and they're selling it for $14. However, they've been out for a little while now, and there's been some problems. They actually tend to overheat, so they're selling a separate little heatsink that you can attach to the bottom. It's got a pad underneath there, which is actually for heat dissipation. Keep that in mind. However, there's also a different camera you can get, which in fact I have here as well, OV5640 Camera, and it has little heat sinks with it. The little heatsink is meant to go to the back of the camera, because the camera, the little module itself, can get warm. And the big one is to be put on the board. They don't give you any instructions, but I believe that that is what it is for. And here they're actually showing that you can put the big heatsink on the little camera as well, but I don't think that that is actually the best way to use it. And they claim that this camera module has autofocusing, although it is totally unclear where the autofocusing is, and it doesn't seem to autofocus, at least not with one of the demo applications that comes from Expressive. Of course, that's not a Seed Studio one, and I must read up a little bit more on it. Maybe there is some information somewhere, I don't know. In any case, so this is what we have. Now, this is the little the extra camera. I believe it is 5 megapixels, and the included camera is actually 2 megapixels or something like that. I might stand corrected, but I can't find very little difference when I plug either one in, at least with the demo software. Now, what I've actually done is I have put this little camera module on a standard TO220 heatsink, and this is the little heatsink that came with it that you can put in the back of the camera, but I stuck it on there for good measure, and this indeed seems to keep the thing cool. And if I ever mount it on in a little project or something, I can actually mount it on there somehow. So so that's what I've got done for the time being right now. And if you look at the other heatsink, the bigger one that came with it, I believe it was meant to go into the back of the board all the time, even though that's not indicated by the, as you saw by the website, the Seed Studio website. And this little heatsink fits perfectly on the back of the board, and quite honest, when it is running all the time with the camera on, this little heatsink almost gets uncomfortable to touch. It really gets quite hot. And this little board here would definitely not be good to use without a heatsink, in my opinion. So that is what we have. And then, as I said, there is a little socket here that this little board normally mounts on. And this little board has a few extra GPIO pins on it. And it also has a socket for one of these SD cards that you can plug in there. I haven't tested that yet, but you would be able to save images on there and stuff like that. It also has a microphone on it somewhere. I'm not entirely sure. Oh, that will be on this board here. Yeah, there it is there. That would be the little microphone. And of course the thing comes with this little antenna, but works perfectly well for like Bluetooth or something like that, because it's close by. But for Wi-Fi, this antenna is pretty useless. It sort of works, but if you're streaming video, you'll get stuttering, and there'll be big, once you move the camera, there'll be big pauses between when the images align and so on. So this is not useful for Wi-Fi, at least not for streaming when you need maximum throughput. So I have an antenna that I cannibalized from an old router, and it has the little socket on there that actually fits on that little socket over here. So we can actually plug that in like so. So now we have a nice big antenna on there, and with this antenna I've tested it. The streaming works pretty well. My router is in another room upstairs in my home, and the Wi-Fi signal is pretty good, but not good enough for this little piece of paper with an antenna printed on it or something. I don't know exactly how that is in there. Okay, so this little board then plugs into that socket. Click like that. So, and then you can actually attach this camera. Is got goes in there like so, and you push the little lever down, and there you go. This is the camera module. It's nice and small. Okay. Oh, actually, while I'm still at it, I made a few videos a few weeks ago. People complained about the sound quality, and I've got a new microphone here. And when I do these videos, I find I need a little lavalier microphone, that you put on your clothes, and it's supposed to have noise cancellation and stuff and all that built in, but there are so many settings in OBS Studio, so I would like to get some comments on whether the sound is actually good for you guys, whether it's clear enough and so on. So you can put that into the comments, if I would appreciate it. From the GitHub site that Expressive has, there's an Arduino-ESP32, https://github.com/expressive/Arduino-ESP32. Okay, and the easiest thing to do is to, what we actually want, the files are actually in this libraries subfolder over here, but it's good to get all of these tools and stuff and that they have, packages and so on. And what you'll want to do is to go to the click this green code button and download it as a zip file. Then when you do that, you can unzip it in a folder, and let's go to the folder where I've already done that. Okay, so I have actually I downloaded it to a folder that I created, ESP32 master, and you'll end up with an Arduino-ESP32-master.zip file, which I've already unzipped into this folder here. And these are all the files that you saw earlier on that GitHub site there. And we want to go to libraries, then we want to go to ESP32, then we want to go to examples, and then we want to go to camera. So of course I've got it on my folder here, but you'll be looking at this part of it here. If you've unzipped the file, wherever you've unzipped it to, you'll be looking for that. And Camera Web-server is got an Arduino, got the Arduino files here, and I actually I converted them and tried to compile them with Platform IO, but it does not compile. This particular file over here has some invalid code in it that Arduino obviously ignores. They are actually assigning, if I remember correctly, what is it now, as time underline t, and they are wanting to treat it as a long integer, and obviously the Arduino IDE allows you to do that, but that's illegal for as far as C++ is concerned, and the Platform IO system uses a more strict C++ compiler. So anyway, so I decided, just for testing, I decided just to load it into the Arduino IDE, which is what I have done over here. This is what you get, and by default this line over here is actually uncommented, but that's not what we have. I commented that line out, and I uncommented this line here, camera model XIAO Esp32S3. That is what we need to use, and of course you got to fill in the SSID and the password for the because this is like a web server that actually accepts the output from the camera through the Wi-Fi, and then displays the results. So I've created a temporary ID and password, which I will promptly delete after this video. So obviously I'm not going to show the real IDs and passwords for my site, just in case there are some hackers around. And that's all you have to do, and then you can go and compile it and upload it. Now I must admit, I've been playing with some of these values over here, and it stopped uploading with some sort of error message after about 24 to 38% that the it wasn't responding or something like that. I have no idea what that was, so I kind of reset it, and now it is working again. But I always have weird stuff happen with the Arduino IDE. That's one of the reasons I normally use Platform IO. Any case, so when we run that, let's close off a few things here. See if that will work. Let's reset it, and it recognizes automatically which camera you've got. I have the little camera plugged in, OV2460, that came with it. And now if I go to, let's get a still picture first, there it is. And let's get a little bit more size there. I find that it likes 800 by 600. Okay, that's a bigger picture there. Now let's go to, there's a bunch of settings over here. Some of them seem to do nothing, and others seem to, I don't really know exactly what they are without doing some more research. I'm not a camera expert. Okay, I've got it streaming now, so I can actually move the camera a little bit jittery because it actually sends it over the Wi-Fi. Now what I find is that this little camera seems to be just as good, and in some ways actually better than that other camera. If I hold something in front of it, you will see that there really isn't much of a, it's always, the focusing on it is always, it's never really sharp. So I guess it's okay for there's a quality thing here, but that doesn't necessarily do anything. You can make it brighter, but if you do that, it just becomes the black becomes washed out. If you give it more contrast, then you can actually make it a bit brighter. But saturation, that's for color. Color looks good to me. Automatic white balance, I think that is. If you turn that off, nothing much happens on this camera. White balance mode, you can set different modes. It seems to me that this little camera that comes with it is actually better than the other one, as you will see. AEC sensor, goodness knows what that is. Alright, so you pull up this little lever there, and then we can plug in this little camera over here, and I will put it in here, and I'm going to do a reset. Now when you compile the program, it actually tells you what IP address to use in after you run it and upload it in the IDE after you. So okay, it has now decided that it is an OV5640 that it is plugged in, and as you can see, we've got a lot more settings over here now than before. What size are we at? Let's go to 800 by 600 again, and it's still. Now the one thing you'll notice is on the dark areas here, I don't know if you can see it clearly, but there is vertical lines on it. I don't know what that is with that camera, if the camera is actually faulty. And also it is now mirror image, so you will have to go and turn horizontal mirror on, and let's go directly to start stream. So now it is correct again, and it's not a great picture, I don't think, and it is no sharper than the 2 megapixel camera is, as far as I can tell. So I don't know if any of these did make a little bit of a difference, but in actual fact, if you look at the letters over here, it actually made it worse. Brightness, contrast. Ask me in the dark areas here that little camera they sent me, there's something wrong with it. It's got these vertical streaks there, and if it's really dark, it is even more obvious. I don't know what that's all about. Sharpness. Can't say that I see much, if any, difference. Denoise. Auto 8. Can't see much difference there at all. Exposure level just makes it brighter. Doesn't do anything for anything else though. I think it's better with a little bit less there. On this camera, the automatic white balance really makes a difference when you turn it off. Advanced white balance doesn't seem to do anything as far as I can tell. Manual white balance. Then you can check, you know, what doesn't seem to do anything. I don't know what GMA means, but it's a little darker. Anyway, that's what we get. And again, that little camera, it's also, it's a little bit better than the other one. I guess you can read it a little bit better, resolution. But okay, so that's what you've got, and it does respond a little quicker, I guess, when you move it. Not quite as jittery. So that's what you've got. Now, what I'm going to do is I found a few projects for recognizing QR codes and so on, and I'll have a look if I can. It's actually made for an ESP32 Cam module, but I'm going to see if I can modify some of those to work with this particular module. Okay, so I wanted to try this little camera module out to see if we could do anything useful with it. And I have already rejected this other camera that's supposed to have a higher resolution, but the thing is that this one is probably faulty. I don't know, unless it is really brightly illuminated. It's got these vertical streaks in the picture, and that stopped the I'm trying to do a QR code, see if it can translate QR codes. It wasn't able to do that at all. So this thing, actually, I think I threw it in the garbage. Now it's sold as to be autofocus, but how do you do the autofocus? It doesn't seem to be part of the software anywhere, and there's no information on how you do that with this thing. So I am starting to think that this particular little module, it's okay for experimenting, but it is not really useful for anything that is serious. For a start, it really gets very hot, and you can't put it in a very small enclosure. It needs that little heat sink, and I've noticed that, as I said before, that Seed Studio is now selling, I think for 50 cents, they sell you a heat sink that'll fit on there. And the pictures that it makes, the images are pretty blurred at any distance. So, but we'll have a look here if it is actually able to do QR code scanning. All right, so what we have is, let me get into the display capture here. I have found some software, and it actually came from Circuit Digest. It had a little article on how to scan QR codes using ESP32 Cam module. Now the ESP32 Cam module may well be better than what this thing is. I don't know. I don't have one, and one of the reasons I never purchased one is because whoever designed it decided to not to put a proper USB port on it for programming and so on. So you have to use an external, as you can see them doing here, an external FTDI module. So I don't, that's not really acceptable to me. So that's why I never bought one. But I think there are some other people out there that actually have ESP32 modules with cameras on them. I'm not 100% sure. I haven't really looked for it. But in any case, I actually have taken the source code that they have. Now they're using an external little OLED display to display the information on. I see no reason whatsoever to do that at this point for testing, because you might as well just put it on the serial monitor. So I've made my little circuit much simpler. I have just got the ESP32 Sense module, and I have only 4 connections to it, which is actually the switch plus the USB port is obviously plugged into the PC, so we can monitor on the serial monitor, and it's powering it as well. I found that all I had to do was to I actually imported it in Platform.io, like it has a facility. When you go to Platform.io homepage, says import a Arduino IDE project, but when you do that, it actually it doesn't rename the file. I like to rename the main file to main CPP instead of what the previous name was, something.ino. But in actual fact, the only change that I had to make to the source code is I did comment out all the OLED display stuff for now. And what have we got over here? Let's go to the top. This I all left alone. It uses the same libraries. They are all there. I put in a temporary SSID and password, as I did before. As I said, once this video is finished, I will delete that. And there is actually the code that actually decodes it. Is actually a server on the Circuit Digest domain, and I have an API key, which I'll show you in a second. There you have to actually go and create a little account and get the key for that. So I had to put that in, and the ESP Sense board does not have a flashlight like an LED that lights up the scene. It doesn't have that, so I commented that out. These were the camera GPIO pins that they used on that module, but on the actual ESP32 Sense module, these are the actual values to use on the pins. And just the display text doesn't go to the OLED module. It just does a serial print line, and that's really all that I've done. That's it. There's no other no other changes needed. So yeah, when you where is it now? Over here, generating the API key. You go to circuitdigest.cloud, and then you register, put your username in there and what have you. And once you've done that, you'll end up you will find that you can after registering, you can use your email ID and password to log in, and on the login page you can actually click my account over there, and then you can go and get the API key, and you just copy it and you will paste that into your code as you saw. There it is, they just pasted it there. So we are actually, I've got it connected to the PC, and once you plug it in, it tells you the IP address that the camera is actually using. It found some PS RAM, and initialization successful, and so now I can start capturing. I am going to push the little button. Did read it, and it came back with the proper code that it represents. Now, interestingly enough, when you go to Circuit Digest Cloud Static, then that's the key that we have, .jpeg. You can actually look at what it read. This is the one we want, and you see how blurred the picture is. Remarkably, it was able to decode that, but I tried several others, and they're a little bit on shiny paper as well, and they just would not work. And they had more, they were smaller, and they had more details, like for instance this one over here. We go back to the camera. This one over here had some more details, and it just was unable to read it. And another thing that I've noticed is, I think this demo software might have some bugs in it, because you will put a code under there, and then you push the button and it says okay, uploading and decoding and so on, so it comes back but null, and then you look at the picture like I just did, and it's actually the previous image that you took. And sometimes you have to push it twice in order for it to register the new image. So I think that this software probably is not discarding the old image when it reads a new one, or something like that. I have no idea. Anyway, as I said, I love these little modules for my little project because they're small. But obviously too, what we found out is if you're running these modules at high speeds continuously, they do get too hot, and you have to add a little heatsink to the bottom of them, which is the case when you're using it with that camera module, because the software is continuously, you know, scanning stuff and so on, and it seems to overheat unless you put a heatsink on it. So that's it, just an experiment to see what we could do, and I guess we'll leave it at that. And I'll see you guys later. Don't forget to subscribe and like and all that kind of stuff. And we'll do something else next time.